Okay, so here we're going to start with number 12. Actually, let's scrap that. Let's go in, let's do a negative one. So we're going to go ahead and do number 14. This is the work from chapter 7, section 1, so 7.1. Number 14. Start with h of x equals negative 2 parentheses 2.25, or is that 2.5? 2.5, not bad. 2.5 to the x. And this is what we call an exponential growth function, and we know that it's a negative growth because of this negative leading coefficient. We're going to come in, we're going to do our x and y, and we're going to plot some points. First place we want to go is when we can get the exponent to be 0. Well, 0 in here would turn this exponent into a 0. So 0, anything to the 0 power is 1. So I have 1 times negative 2 is negative 2. Then the next calculation would be when I can get the exponent to be 1. So I'll put a 1 in for x, and then 2.5 to the first power is 2.5, and that times negative 2 is negative 5. Alright, so now I can go ahead and produce the graph. I know that at 0 I'll be down at negative 2, so right there, and then at 1 I'll be at negative 5. Now it's important that we realize that all of these graphs flatten out on the left side, and then they start to grow as they go to the right. And that because there's no addition subtraction, my graph is going to hover right below 0. And then it's going to start to turn, and it's going to turn more and take off this way. One last thing is to do the domain and the range. The domain for all these functions, it does go left and right forever, so we're going to say that it's all reals. And the range is going to be y. If you notice, all these values are going downwards, so we're going to say less than. And what's that value up here that we can't approach? We can get close to but cannot cross 0. And so we're going to say that y is less than 0. Not equal to today because we're not able to plug 0 in or get 0 for y. If we were to try to solve it, we get close, infinitely close, but never touch. Okay? When we move to 22, we can get a positive 1, and we're going to see some shifting and some moving around. And so we start there's my graph, here's my xy table. Initially, I'd want to try and use 0 up here. But you see how it's got that plus 2, that grouping of 2? That tells me to take the opposite sign of it and use it. Well, negative 2 plus 2 is 0. And 3 to the 0 is 1 times 5 is 5. 5 minus 4 is 1. Now, I also want to get a value of 1 as an exponent. So if I put a negative 1 there, negative 1 plus 2 is 1. 3 to the first power is 3, times 5 is 15, 15 minus 4 is 11. Okay, so this grows pretty fast. Okay, so I'm going to come out here to negative 2 and negative 1. I'll go up to 1. That would be this guy right here. And then I'll go up to 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'll put a dot right about there. Now, if you notice, there is some subtraction in here, specifically right here that I'm worried about. This tells me that when I go down to negative 4, that is going to be the new 0 that I approach but don't cross. I'm going to start out way over here and turn up like that. Okay, and there's my new curve. My domain, of course, is all reals. My range, though, is y. As they are all bigger, it's growing. It's greater than. And what's that value I can't touch or cross? Is negative 4. It'll always be that value right there. Okay, so there's my graph. Here's my equation. 28 asks me to use the equation a equals p times 1 plus r over n to the nt. Now, we know that p stands for our principal. A is our amount, or typically it's money, but we're also going to apply this in 28 to the number of birds that we find on this island or area. R is going to be the rate of growth. N will be the number of times it's surveyed or compounded. How many times the value is checked or evaluated. Of course, that's the same there. And then T is the number of years at any given point. Okay. So we're going to start with A equals the little statement here says, in 1992, 1,219 monk parakeets were observed in the United States. For the next 11 years, about 12% more parakeets were observed each year. So we're trying to write a statement for that. And well, we have to realize that, first off, P is going to stand for the principal or the amount put in. Well, initially, that's going to be our 1219. Because that's sort of our starting number. It's where we're beginning everything. We'll have 1 plus. It said that we have a 12% increase. So 0.12 for my rate. Now, the number of times that I have increased, the number of times I compound, is kind of in the statement. It's kind of hidden. It says for the next 11 years, about 12% more parakeets were observed each year. And so we're going to say that this was only counted or dealt with once a year. And then we'd have 1 again for n, and then, of course, a t there. This is pretty good. I know in the textbook we simplify a little bit further, and that's what I'd like to do. You won't do this step on all of them, so just be aware of that. I think 29 we didn't do it when we did it in class. We didn't have to simplify. And then number 30, it looks like simplifying would be a good idea, but again, you don't really have to. When this is a 1 for the number of years, the n is 1, it's nice to simplify. So I'm going to have 1219 times 1 plus 0.12 is 1.12, and then 1t is just t. So this is my final answer. This tells me I've got that 12% growth. You know, it's 0.12 more than 100, or more than 1 full percent, 100%. So that's really it. Hopefully that's enough to get you going, and let me know what questions you have.